I'm just using this video to hopefully make sure you fully understand what's happening now. So we have a function, x squared plus 2x. I just quickly graphed it here. Not a great graph, but it's fine. It'll do for this. You could, if they asked you to differentiate, you could differentiate from first principles. I'm not going to do that. I'm able to use the log tables. So where I always start is on the left hand side here. And if it looks exactly like something that's on the left hand side, then I can just apply this rule and get the differentiation of it much quicker than using differentiation from first principles. So my function is x squared, 1x squared plus 2x. So that's, let's say a 1x squared plus 2x to the power of 1. Do I have a variable where the power is a number? Yes. So it tells me, bring the power down in front, subtract 1 from the original power. So the 2 goes down in front, and I subtract 1 from the original power. Plus, the power goes down in front, so 1 this time, and I subtract 1 from the original power. Clean this up. I have 2 times 1 times x to the power 1 is just a 2x, plus 1 times 2 times x to the power 0. What is x to the power 0? Anything to the power 0 is 1. So that's 1 times 2 times 1, which is plus 2. Now, what have I just figured out? I have figured out the formula for the rate at which the curve is changing. In other words, I have a formula now for the slope. So let's look at our function. The formula for the slope is 2x plus 2. Now let's make sure we can make sense of what this actually means. So if I look at this, a quadratic, depends, here, 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 anywhere, they have all different slopes. Like it looks to be maybe a slope of 0 around here. So that I can maybe pick out from the graph if my graph is done right. Maybe that's a plus slope anyway. That's a steeper plus slope. So if that was 2, that'd be maybe a bit steeper again, 3. Over here we have minus slope. So maybe if that was a minus 1, this is a bit steeper again, it'd be a minus 2. So that's just me estimating. If I want to know the slope here, let's go for here. At x is 1. So when I'm looking along here and I can see that the point is 1, 3. So the x coordinate is a 1. 2 times 1 plus 2. 2 times 1 plus 2 gives me 4. The slope at that point there is 4. Let's try maybe here at minus 1. So it looks as though the slope is 0, but let's just check it out. So 2x plus 2 is the formula for the slope of this, which is what all this work for here is. So 2 times, so when x is minus 1 plus a 2 gives me minus 2 plus 2, which is 0, slope of 0. Yeah. So we're just looking at fast ways now which we can find the slope, not just of a linear function, which we did in coordinate geometry, but now you didn't exactly, do functions in coordinate geometry, but it was helpful. So this is a quadratic function, and we didn't look at anything to do with quadratics in any other section really. So now we're going into it in more detail here, and we can find the slope at any bit of that line, that function.